Yeah, Malaysia is also, right? Yes. To start this one. Hello, hello, hello. Hello. Okay. Hello. Okay. Okay. So for everybody, if you can come to the front, it will be easier because I have to write here. So there is empty seats, then you can see better, just for you. Okay. All right, so welcome back. I know it's 5 o'clock, and what a good way to talk about statistics at 5 o'clock at the end of the day, right? We will try to make it as much fun as possible so that we don't sleep here, even though I probably was the first one to get awake this morning. I woke up at 4 a.m. because of jet lag. I still feel like sleeping at this moment in my bed because in the US it's like midnight probably. So if you find me sleeping, wake me up, okay? And it's good to see all of you here. I actually thought that I'm going to talk to 3 or 4 people here because there was nobody earlier, right? So it's good to see you all come back. Feel free to stop me when I talk about the stuff that I'm going to talk about. Uh, it is statistics, but there's a lot of technical issues. The problem is laptop is in the back. So if I have to use my laptop, I have to go back, which would be weird because I'll be talking from the back and you won't see anybody in the front, right? So we'll try to make it work. That's what we learn in PhD and research and everything, try to make things work. So I'll see if Siddhan can help me with the smart PLS later on, but for the first probably hour and a half or so, it's more of a lecture type of thing. So I try to explain some concepts that a lot of us need clarification on when it comes to SCM. And then later we can work on the software. Now, for those of you who are here, I will give you a URL. It's a simple URL where you can download some resources for this workshop. So if you go to Let me see if I have it here somewhere. So then one more slide. Do you see a QR code or something there in the slides, Siddhan? Okay, probably it's not here. That's okay. If you can just simply go to tinyurl.com. It's a website that reduces the URLs, right? So tinyurl.com/mtconpls. Okay, so it's very simple, tinyurl.com/mtconpls. There inside you will find the PowerPoint slides that I'm using, as well as other sample data sets and models and some other things, that some helpful literature for PLS and SEM. So all of those things are available on that URL. Make sure don't edit it, because if you edit it, it's on cloud, right? Whoever edits it, everybody is going to see the edited version. So just download it for your own use and we can go from there. Okay, with this out of the way, oh yes, one more thing. I have a good friend who is also developer of Smart PLS, Christian Ringel from Germany. I asked him to give me free license for everybody who is attending today. So I'll also give you a code for 2 months of free usage of PLS. That way you can have 2 months of free usage for, playing with the software. All right, my name is Faizan Ali. I suppose most of you know who I am. For those who do not know, I'm an associate professor at the School of Hospitality and Tourism Management, MoMA College of Business at University of South Florida. I have started using PLS since 2013, which is way early. Back in the days, they had a version of PLS called Smart PLS 2. You had to do a lot of manual calculations at that time. Also happy to say that I'm one of the initial people who worked on PLS in hospitality and tourism research. So at that time, we had to do a lot of hard work to satisfy the reviewers, because reviewers were never happy with PLS. To this day, there's a lot of questions when you use PLS. People ask a lot of questions, why you are using it, justify, blah, blah. The good thing is now we have a lot of resources to justify the choices, right? Back in the day, 2012, 2013, there was not a lot of literature out there. So now there's a lot of literature. There's a lot of good people who are working on PLS, and then you get a lot of material that you can use to justify. Now, having said that, please know that PLS is not a one solution for every problem, okay? Earlier this morning, a good friend of me and my mentor, Professor Fevzi, he did mention about methods, right? So he said everybody is using SCM, and then later in another keynote, Professor Kathy Su, she also mentioned methodologies and methods. So just know that we don't have one thing that works for everything, right? So just imagine if you go to a doctor and imagine your doctor tells you, go and test your eyes for every problem you tell the doctor, right? It would be like this. So we cannot do things like that, right? So you are going to use methods where they are applicable. If your research is very simple, or if your research questions don't need it, you don't need to use these type of things. Just make sure that you use it as a tool in your toolbox. But that toolbox has other tools that you can use for the right situation or whenever they are needed. Okay. So then next, please. This doesn't work. All right, so what I'll focus on in this very quick lecture is first, what is SCM? It's important to know what SCM is. For many people, SCM is a way to publish, right? So you need to put SCM in your paper to get published. It's okay, yes, if you are targeting a low-level journal, but for many top journals or even mid-tier journals, that's not accurate. So we'll talk about what is SCM, then a little bit about the difference between covariance-based SCM and partial least squares. Then some issues, methodological issues when it comes to PLS. We'll also talk about when should you use PLS, what are the right ways to use them, and when you should use them, plus some recent advancements in PLS. Now remember, PLS, just like any other discipline, is academic discipline, statistics, right? We had earlier, somebody was presenting Burju. Burju is not here. She was presenting and she said her area of focus is quantitative research methods, right? So just like any other area of research, statistics and quantitative research methods also develop, right? Develop over time. So if you learn something from 2012 and 2013 and you are still using the same reference or justification, it's not going to work. You need to make sure that you are up to date with all the literature or recent advancements when it comes to PLS or SCM for that matter. And then lastly, we'll talk about some misconceptions about PLS. It's surprising that what I'm telling you right now, reviewers are also the culprits. So sometimes I get reviews on my papers where the reviewers are suggesting rejecting my paper because I use PLS, but they are giving me references from 2012. So whether you are an author or a reviewer, right, either way, you need to keep yourself up to date with whatever the literature is in that domain. All right, next slide, please. Okay, all right. So I actually you know what, I'll just skip this one. I'll just simply tell you that my research area focuses on hospitality and tourism, consumer behavior. I also work on recent research methodologies. I feel that there's not a lot of research that is done on research methods itself, right? So we are very out of date when it comes to research methods. Many of us normally go to textbooks when it comes to research methods to look at textbooks and read those textbooks, which are oftentimes outdated. So we don't see the recent debate on different methods, right? Earlier, I was chairing a session. Some good people in this room were in that session. We did have a very good discussion on usage of Amazon MTurk, right? So some of you know Amazon MTurk to collect data. And it's a good way to discuss these things because we all use them in our research, right? So my area of research also aligns with research methods. So I do some research papers that focus on particular research methods and how to improve them. Now, I am no expert in statistics. I have no degrees in statistics. I have never taken a course in statistics. Never in my life I've sat in a course for statistics. Whatever I tell you is my self-learning from my experience in different journals, in editorial roles, in reviewer role as an author, because I try to keep myself up to date with whatever is happening, right? So if a reviewer is commenting on my work, I don't feel, I mean, of course I feel bad. I actually am very angry with the reviewer, but after a day, I go and start searching about it and try to make myself up to date with what they are asking. Recently, Professor Levent and myself, we did a paper together. We submitted it with PLS, even though I thought whatever we did in that paper was up to date, completely up to date. But the reviewers ask us something which we normally do not talk about in PLS, right? And they ask me about endogeneity tests. Now, normally we don't talk about those things, but first, I was in the state of denial, right? So I look at this comment and I feel this reviewer is so stupid, doesn't know anything, right? And then the next day I thought, well, whatever the reviewer is, we need to go past it, right? So I have to respond to the reviewer. So I started reading more and more about it, more and more. And I'm happy that I did because it ultimately improved my own knowledge of the issue in PLS, right? So whatever I will talk today, of course, there's a lot of literature support for it, but these are things that I learn over the years. It's not one day thing, it's not 2 days thing, it's like over the years learning this stuff. Okay. Yeah. Earlier, Professor Fevzi was saying, try to keep a hobby. I do a lot of hobbies, so I love nature. I go hiking, I do nature and stuff like this. I love animals. Okay, and I love cooking, even though I can only cook one thing, which is fried egg. But these are my hobbies and they keep me in sanity, not insane, but in sanity, and keep me productive with a lot of stuff. Okay, I don't know why it's not working. Oh, no. Need to go back. Yes. Okay, so we are not going to talk about all these things, but very quickly, has anybody used PLS in their research? Okay, 1, 2, that's 3. So, okay. Okay, so not too many people. Those of you who used PLS, did you get any comments from reviewers for your research paper? Good, bad? Uh-huh. Hard. Okay. Amal, your supervisor was not happy? Okay. And Carlos, how was your experience? Mm-hmm. Exactly. And it's the good thing about these methods is that you don't need to specifically go into specific journals, right? I mean, normally if I'm doing something in hospitality, I would go to hospitality journals to justify things, right? The good thing about PLS or any other method for that matter is you can go to mainstream business journals. And in fact, one of the top journals, FT50 journals, is Journal of Academy of Marketing Science in my field, right? They publish a lot of papers on PLS, methodological papers, where you can go and see what's going on. Some of you may know HTMT, the new method of discriminant validity, right? It was published in a Journal of Academy of Marketing Science. So try to improve your own knowledge by going into this recent literature. And most of the journals today, actually you can ask this of the editors in the editor panel, but most of the journals today also provide RSS feed. So if you go to RSS feed, every time there's a new paper published or whatever, you get a notification and then you can read that paper. You can also set up notifications on Google Scholar. So just simply go to Google Scholar, set an alert, and every time there's a new paper published in that particular topic or whatever, you get a notification, and that way you are up to date with recent developments. So let's move. Okay, all right. So let's go to statistical methods. Siddhan, can you please, you know, all right, okay, this is enough. Okay, so just like anything else, statistics also have a progression. It started somewhere and then it's moving somewhere else. So initially we had first generation statistical tools, right? First generation statistical tools were initial statistical tools, right? That people started using when it came to probability or large chunks of data and things like this. Now, in these first generation statistical tool, there was a problem. The problem was we never thought about the error term, right? Or errors that are included in measurement. What does that mean? It's very simple idea. The idea is, let's say if I am collecting data about experiences, right? Somebody earlier presented a paper on experience in different places. So let's say if I want to ask you about your experience, right? Let's say, Sanaz, I want to ask you, how was your experience flying with Sun Express, right? Now you flew the day before last night, yesterday you flew. So if today I ask you, tell me your experience, right? Are you telling me your experience or are you telling me the memory of your experience? The memory, right? And what happens with memory of experience is it gets biased, right? Why? Because yesterday when you and I talked, I also told you my experience with Sun Express was terrible. So which makes your bias even higher because now you think even more negative, right? Because we talk about negative experience. So what happens is when I come to really measuring experience, I'm not measuring experience. I'm measuring memory of experience, one. Second, I'm measuring something that includes biasness, right? So whatever comes to me is not actually what I wanted to measure. This is what measurement error is, or which is what error is called. Now, most of the research is based on questionnaires, right? Most of the quantitative research we look at, it's used based on questionnaires. And you may have seen that when you go to methodology section, it says that I collected data from people 18 years and plus. I also collected data from people who stayed in a hotel in the last 24 months or 12 months. Yes? Okay. 2 weeks ago, I was in North Cyprus. I stayed in a hotel called Arkim, right? Arkim Palm Beach. Now you imagine this, 2 weeks ago, I don't even remember the name of the place. You ask me, 24 months ago, you stayed in a hotel, tell me your experience. How am I going to tell you? Right? There's a lot of error in it, right? So I can give you a memory of my stay, but you know that memory is so biased and all this stuff, blah, blah, right? How many of you remember clearly about your hotel stays before COVID-19? My memory is gone. It's like I had a memory loss completely pre-COVID-19. I don't remember anything, right? This is what the error is, right? So with the first generation of statistical tools, there was no way to incorporate this error into our measurements, right? So we couldn't measure the error into the measurement. And we had these different type of tools. But anyways, just like any other thing, people realized this problem and then they started talking about this error. And they started including error term into our mathematical calculations. Now, how many of you have used AMOS? software? Literal or Amos? So you know there's something called error term, right? There's a small e with everything, which is actually including error term into your measurements, right? So after first generation tools, we move to second generation, which is here. So in the second generation, we started including error terms. Now, there's one error, and then there's another thing with the first one. And the first one, the first generation tools were only looking at observed variables. Now, what is observed variables? It's very simple. Like I said, if I want to measure your, let's say, perceptions of service quality in this hotel, right? Now we are in this hotel, right? And I want to measure your, what do you think about the service quality of this hotel? So what do? I go to the literature, right? In the literature, I try to find a scale. Yes, this is what we all do, right? I go to literature, find a scale. Now, most of the people have used a scale for service quality called ServQual, right? Do you all know ServQual? Right? It's a service quality measurement scale. So you say I'm measuring service quality, which looks like this. Okay, and in your questionnaire, then you put one question, you put another question, another one, and in front of this, you put a scale like this. Strongly disagree, disagree, neutral, agree, and strongly agree. Does it look familiar? Yes? Okay. Now, can somebody tell me, is this a variable or is this a variable? Uh-huh. Mm-hmm. Exactly, here we go. The items are observed, meaning that these questions, 1, 2, 3, these are the questions that you are directly observing, meaning you give it to your respondent, they respond back based on these questions. So let's say this person selects this person selects this, so you are directly observing them, right? Now, my initial objective was to measure service quality, right? But I didn't measure service quality, I measured different sub-variables, right? Or some observed variables. So with the first generation of statistical tools, the problem was it was only working with observed variables. You all use SPSS, right? When you put data in SPSS, do you put these questions or this one? Observed variables. Now, with the observed variables, there's a way to bring your latent construct, and the best way to do it is take an average. You go to create a new variable, and then you take an average of these. Yes? Okay. Now, the problem is, one, we are not directly measuring this. The second problem is, with each of these, there is error. And we did not account for that error. When in SPSS, when you put your data, there's no way to account for error, right? So now what the problem is, when we take an average, we are also including an average of error in there without accounting for it, right? So this was the problem with first generation statistical tool. We moved on to second generation tools like structural equation modeling, where we try to counter these problems. So those of you who have worked on Amos, Literal, Smart PLS, or any other modeling technique like this, you will see that in that model, you put observed and unobserved variables together. So you have the variables, you have the latent variables, observed, everything all together, right? Plus error term. We tried to counter that problem with the second generation techniques. Siddhan, can you move further, please? Okay, so here we go. Now in this one, we are measuring our structural model, measurement model, latent variable, unobserved variables, everything all together. So we counter that issue. Can we go ahead one slide more? All right. So now we talked about error term a little bit, but it's important for all of you to understand why is it important, right, with the error term. So normally in research, we have two types of errors. Okay, two types of errors. One is called random error, which can happen with any of us, right? Okay, so let's assume you leave your room in this hotel, okay, and you are coming down to this hall, and every day, right? There's 4 days of conference. So let's say this morning you leave your room and you slip a little bit, okay? That's okay, it can happen to any of us, right? But let's say tomorrow you leave your room and in the same place you slip again. Then the third day, in the same place you slip again. The fourth day you slip in the same place again. Is there a problem? Right? Maybe there is some broken thing there. Maybe the level of the floor is not accurate. I don't know, maybe some problem, right? Because of which you are slipping in the same place again and again, right? So that type of thing is called systematic error, where you are observing a trend in an error. So when you observe a trend in an error, then that's problematic. You need to go back to your data set and see what's wrong, what's going on. Okay, let's assume for a moment, this is my data, and I am trying to input this data into SPSS, right? So I pick up question number 1, and then I go to SPSS and I put like this, right? Then I go to question number 2, there I put like this, right? Out of those 5 scale. Then I go to questionnaire number 3, and I put like this. Do you see an error? Yes? This one, right? It can happen. I mean, when you input data or something, it can happen. Now, however, if you see like this is an example of systematic error, where you are seeing the same error again and again and again and again and again and again, right? So then it means that you have some issue, right? So go back to your data set and see what the problem is. And it's important to deal with, because normally we go based on, whenever you do SCM and these type of things, normally the assumption is data should be normally distributed, right? In your sample, your data points are from 1 to 5, but then you also have 55 in a lot of places, which means these will all be counted as outliers, right? So it creates problem for your analysis, and that's why it's important. So we need to make sure this. Now, how do you deal with this type of issues? There's 3 reasons why our data might have problem, right? An error. Number 1, and the most important one, is poorly worded questions and survey. This is the most important reason why we get error. Okay, why is it? Most of us who use questionnaires to collect data in our own countries. So let's say if my friends here from Iran, if you want to conduct some study in Iran, okay, general consumers, what would be the best way to use your questionnaire in English or Persian? Persian. Now, how many scales are developed in Persian? Not many. So you are going to get a scale developed in English, then convert it into Persian, right? Do you think every single word in English has an exact match in Persian? No. So you have to find something related, which sometimes can be a poorly used word in another language, right? So it happens to a lot of us, right? Sometimes you get a questionnaire in another language and convert it into English, and then it becomes a different thing, right? So that's one reason why we can get error. The other one is incorrect application of statistical methods. Now, what does that mean? It's also very easy to understand. So if I have a variable like this, let's say satisfaction and loyalty, and this is my H1, right? So normally you develop this after your literature review, right? And the statement here says that satisfaction is positively related to loyalty. Yes? Or satisfaction and loyalty have a positive relationship. This is how we hypothesize, right? But then I go to analysis, and in analysis I see regression-based modeling, or SCM, right? Okay, now what's the problem here? When you use a hypothesis saying that satisfaction and loyalty are positively related to each other, you are basically hypothesizing, correlation, right? However, your analysis is regression, which is a different thing, right? So it also creates some issues. It's an error in judgment. How do you interpret these results? Because these two are very different, right? So let's say if my sister is standing here and somebody asks me, what is the relationship between both of you? I can say we are siblings. This means I'm talking about the relation between both of us, right? She is my sibling, I'm her sibling. It's a different way. But let's say if somebody asks me, how is she related to you? Now the question is one directional. So I say she is my sister. So I can tell you my relation with her, but I'm not telling you her relation with me. You can assume it, right? But it's different. Both of these are different. And you can also see statistically, if I say regression, it means how this one is impacting this one, right? This is what it means. But when you say correlation, then it becomes like this, how both of them are related to each other, right? So this also creates error into interpretation of our results, right? So we should avoid this one. And then the third one is misunderstanding of scaling approach. This is also very important. So recently, one of PhD students reached out to me and said, Dr. Faizan, I need your help with something. And I was like, okay, tell me what it is. So he told me that I am trying to understand the skills that are important for people upon graduation before they go into industry, right? So we have a lot of students, undergraduate students, they are studying hospitality. And then after this degree, they are going to go into industry. So I'm creating a list of skills that are important for them. So I asked him, okay, tell me, how did you come up with this? So he said, I interviewed a lot of people, blah, blah, and this is a list of 20, 30 different skills. Okay. Then I asked him, your research question is, what are the most important skills, right? So now you have 30 skills, but not all of them are most important. So you have to pick up some of them, right? So he said, yes, I picked up half of them. And I asked him, okay, tell me, what was the procedure, right? How did you pick up half of them? So he said, I put all of them. I did a survey asking people which one of these are the most important for you. They all picked up on a scale, right? From 1 to 7, least important to most important, okay? And then I picked up the skills that are above the median or average, okay? Now the problem here is this. So if this is my scale, right, 0.1 to 7, this one says least important, and this one says very important, okay? And somebody tells me that, okay, this 4 right here is my midpoint. So anything below 4 is not important, and anything above 4 is important. This is what he told me, right? So I told him, okay, tell me what's the difference here? 3.9 and 4.1. And then these are whole numbers, so we can even go lower than this. 3.99, 4.01. How much of a difference is it? Can you really tell me like something 3.99 is not important and something 4.01 is important? Yes. And this is exactly what I said earlier. We find limitations and try to cover them up, right? But right now with error, these are another example of how error can misinterpret our judgment of things. So remember that when we do scales, right, all the measurement scales, they also have some bias in them. There's also some sort of embedded error into it. And it's important to measure for those type of error things, right? Error, judgment error, or measurement error, things like this. Very important. Now, can we move to next slide, Sadan, please? You know, I will just keep this one because it's not you working anyways. So, okay. Now, because of these problems and all these things, we work with SCM, okay? SCM is what we bring measurement, we bring structural model, we bring latent variables, observed variables, error terms, everything together, right? So usually what happens is when you have a lot of variables into your model, right? When you have a lot of items into your model, when you have different type of measurements in your model, then you need a powerful technique to deal with them, right? And usually the phenomena that we study in social world, right? In social world and social issues, there's always no one independent variable and one dependent variable. There's a lot of things working, right? So we need powerful tools to incorporate all of these things together into models. And that's where SCM comes into picture. And obviously this method also have limitations. I'm not saying this is the best method, right? But this is the method that we have currently for dealing with regression-based modeling, right? So move one slide further, please. Yeah, so usually there's multiple algorithms or multiple methods of SCM, but the two most common ones are covariance-based SCM, and then the other one is PLS SCM. Normally people feel they are opposing each other, and that's very true. They are very opposite each other. And the reason why they are opposite to each other is because their underlying assumptions, like the assumptions for both these methods are different, okay? I will give you some example. Siddhan, please just bring everything on the slide. Yeah, okay, thank you. Now, the first, and later in the slides, I'll explain this more, but usually think about this like, if you want to see how far is this place here to airport, right? If you just want to make sure to understand how far is this place to airport. So what is going to happen? There's two ways of doing it, right? If I want to do it. One is I take out my phone, I go to Google Maps, I put this place, the airport, and see how far it is, right? This is exploratory method, meaning I'm exploring by myself, right? Okay. The other method is I already found out from Google, okay? And then it shows me it's 20 kilometers. But last night when Siddhan and Sinan were driving me, I was very sleepy. I don't think it's 20 kilometers, even though Google Maps show me, right? So what do? I go to maybe Gohan. He is experienced in this city, right? Because he is from this city. I ask him, Gohan, is it really 20 kilometers from here to airport? He tells me yes, right? This is the second method of checking how far is the airport from here. But this method is confirmatory, meaning I'm simply confirming, what I know, I'm trying simply to confirm, is it really like this, right? Now you think about both these, they are very different from each other, right? In one, I'm doing a lot of things because I'm exploring. In the other one, I'm simply confirming things because I already know it, but I'm just confirming it. With statistics, it's also like this. Okay, it's pretty much like this. Now, for example, if I am trying to study how important is lighting in a room on engagement of students in a class, right? Let's say I just want to study this one. One approach is where I go into literature, find out a relevant theory which explains this phenomena, and I confirm it into my study, right? Easy. The other phenomena is I go try to interview people, try to talk to them, blah, blah, and try to explore this even further, right? So exploratory, confirmatory, both are very different from each other. And this is one way of looking at two methods being different in their assumptions. These are two different assumptions. Okay, now, if I am exploring something, right, let's say if I'm exploring something, I give myself a little bit more cushion to make error because I'm exploring, right? I'm not confirming, I'm just exploring. With confirming, we don't have a lot of options. We just have one theory, we are confirming it, right? This is another difference in assumptions. I'm just giving you some examples, not statistical examples, but general examples to make you understand things, right? So with CBSEM, which is covariance-based SEM, and PLS-SEM, there is some difference in its assumptions and how we apply them and how we interpret them and everything. Now, if you ask me, Professor, okay, I understand this, but should I use PLS or should I use CBSEM? I cannot answer you. Okay, if you simply ask me, should I use PLS or CBSEM? I will simply tell you, I don't know. Because this statement is very true. This statement says that the choice between these two approaches is not very straightforward. Why? Because each research project is a different research project. There's a lot of factors to consider, right? One is, what is your research objective? Are you confirming things or are you exploring things, right? What type of data is available to you? Is data very problematic or is data not very problematic, right? The third one is, what type of respondents you have. Do you have too many people telling you something or do you have a few people telling you something? So all these things will really determine which method I'm going to use. Make sense? Any questions so far? No? You know, when no questions, what does it mean? Either you understand everything or you understand nothing. Everything? Okay, I will take a test and then. Okay, so then please, next slide. Yeah, you just bring everything together. Okay, so sometimes it's funny. I read different journals and I respect everybody's opinion. That's completely fine. But unfortunately, I've seen many not many, a few journals who have put it on their website saying that if you use SCM, you will get desk rejection, right? It doesn't make sense to me because it's a method. Now, I understand it's overly used. Many people used it and everything, blah, blah, but it still is a method, right? And what are you going to do if you still need it? Now, do you know which one is the most commonly used medical equipment in the world? Thermometer. Medical equipment. Thermometer, right? You go to any doctor, even you don't have fever, they give you a thermometer to check your body temperature, yes? Can you go to any doctor and tell them, you know, everybody use thermometer, don't use it? You don't do that, right? If somebody's blood pressure is high, you go to a doctor, they are going to use the pump to check your blood pressure. I mean, why would somebody say everybody uses blood pressure, so we are not going to use it? Or you don't enter my clinic if you are going to ask me thermometer. Nobody does that, right? I personally believe it's some method, and if it's needed, you should use it. Why would a journal reject a paper, desk reject a paper because you use the method? Now, yes, if you don't need it and you use it, that's a different story, right? I think paper should be judged really on the contribution and not really the method they're using. It's a bit funny, but generally, why would you use SCM? These are some of the benefits. So obviously one of them is if your model have a lot of indicators and the model is very complicated with too many variables and mediators and moderators and things like this. If you want to use the unobserved variables, observed variables, and the error terms, then it's another reason why you should use it. And then sometimes we also have you know, direct and indirect relationships and things like this, which I'll talk about very quickly. Mediators, you all heard of mediators? Mediator, yes? So that's another reason why we can use SEM. So then next slide, please. Okay, so now when it comes to limitations, of course, just like any other method, there's also limitations to SCM, right? It's not all perfect method. There's obviously limitations. Now, in limitations, I'll tell you what are the limitations of each of the method, right? Because there's two main methods and they obviously have limitations. So the first one is CBSCM, covariance-based SCM, okay? So remember that you can only use covariance-based SCM if you have a strong theoretical support. Okay, why? Because CBSEM is confirmatory in nature, meaning its nature is confirmation of theory, right? So you cannot confirm something if there's no support for it, right? So you can only confirm something if there's support to it. So when you use CBSEM, you need to make sure that there's strong theoretical support for it, okay? That's very important. PLS, on the other hand, is exploratory in nature. Okay, it's exploratory in nature, so you can use it when you are exploring things, when you are trying to understand the phenomena. So it's a bit lenient. The second one is CBSEM uses model fit. Now, what does model fit mean, right? So do you all know of things like NFI, CFI, RMSEA, all these things, right? These are model fits, okay? What does a model fit mean? It doesn't mean anything, okay? To many people, it means it should be higher than 0.9, right? I ask people, what is NFI? They say it should be higher than 0.9. I know this, but it simply means that the model that you have, the model that you created in your software, Israel, Amos, whatever, and the data that you have, right? So the data set and the model, they fit each other, meaning your data is fit for your model, right? Now, sometimes those of you who know if your model fits are not good, like if your score is not 0.9, what do? Delete items, you do modifications, right? You delete items, you connect some items, right? What are you basically doing? You are changing the model to fit the data, right? This is what you do. It's like you go to a tailor, you ask the tailor to make a shirt for you, and then you go and check it, right? It fits you or not. If it doesn't fit you, they're not going to cut your body, right? They're going to change the shirt. That's what we do with data, right? You cannot change the model because the model is already done, right? You already have the variables and everything. But now you are trying to make adjustments with how to make sure that your data and model fits. Now, that's completely fine. People do it and there's no other way, but there's a very big problem, okay? How many of you think data collection is easy? Good data collection. Difficult, right? Okay. So now assume for a moment that I am collecting data from 500 people. Okay, 500 people. And then I go and do my analysis. And then now I want to delete one item, right? So one item meaning one question from my questionnaire. I want to delete this. Do you know how many data points I'm deleting? 500. Meaning there is 500 responses for that question, right? So when I delete one item, I'm deleting 500 data points. It's a lot of data, right? So normally when you are doing your research, you avoid doing this, you avoid deleting data because deleting data means you are deleting information, right? Just because of something. So what we need to do is we need to understand how and when do we use model fit indices, right? Now, if you go to a tailor, okay, clothes, right? Let's say I go to a tailor and I tell that tailor, why you didn't make my shirt fit to me, right? And the tailor tells me, you never came to me to make a shirt for you. Why are you asking me, right? Now, remember, to make sure to fit something, I need to have it. Yes? If I don't have something, how can I make it fit, right? So for confirmatory research, what you are doing, you pick up a theory and you confirm it, right? So for confirmatory research, you have model fits, meaning you have this theory, you are confirming it in another context. Now you have model fits, NFI, CFI, this, all these things. PLS is exploratory in nature, meaning you're not confirming anything. You are exploring things. If you are exploring, you don't need model fits, right? So PLS does not give you model fits. There's no model fits in PLS. Now the recent updates include some model fits, but I'll talk about this one later. Generally in PLS, there is no CFI, GFI, this I, that I, all those things, which sometimes reviewers ask. Okay, this happens. Reviewers say you used SCM, but you don't have model fit, right? So you need to know that PLS doesn't have model fits. And I just told you the reason, okay? Any questions so far? Yes. What about? Okay, so when I say you cannot change model, it doesn't mean you can't change model. I'm saying you cannot delete more things from it. Like you don't avoid deleting things from your model first. Now, about alternative models, I personally do not agree to alternative models, okay? Many people do, I don't, okay? I'll tell you why I don't. So you make a model based on your judgment of literature review, you created hypothesis, then you make a model. Now you are testing the model, right? To confirm it, whether it's true or not true. Now, some people at the model stage create one model, but then they also have alternate models, okay? To me, it's confusion. To me, it's like, okay, you are not having one model and you are giving me 3 or 4 models. Now, you may ask me that, but professor, there's multiple explanations for one thing, right? We can all have multiple explanations. So I would say that yes, we have multiple explanations, but you need to confirm your first explanation first. If it doesn't work, try to see what's wrong with your data, recollect data, change the model, and then test it again. How is it possible you have one data and you are trying to mix and match and see which one works, which one doesn't work? It doesn't make, I mean, to me, it doesn't make sense. Many people do it. I just don't believe it's the right way to do it. Okay, yeah, yes. Go ahead. Mhm. Right. Again, very good question. Okay, so before I answer your question, let's say I buy a Ferrari. Okay, Ferrari, you know Ferrari, right? Okay. I buy a Ferrari, I start driving it, and I go and hit it in this wall, right? Will you say the Ferrari is so bad? Or will you say the driver is bad? Driver, right? Yes. So, so yes. So you need to understand, I mean, there's a lot of published papers, but not all published papers are correct. Now, if you see something wrong in a published paper, doesn't mean it's the right way of doing it, right? That's one thing. But what you say is a different thing, okay? So statistical tools have their own assumptions, but then research strategies have their own assumptions, okay? When you do quantitative research, right? For quantitative research, you need some sort of backing to develop your model. So when you are creating your model for each hypothesis, you need to have support. You cannot put arrows by yourself, right? You need to have support. That is a different thing. If you are trying to find support for each hypothesis into your model, it's a different thing. Strong theoretical support is a different thing. Okay, strong theoretical support means that the model that you created, it's already established, well established. I'll give you an example. ServQual, you know ServQual, right? Service quality. If you go to its citations, it has over 100,000 citations, meaning people have used it everywhere. There's possibly no other application of ServQual. Let's say you find an application for it, and then you use it. This is strong theoretical support, okay? Really strong theoretical support. But then Carlos here recently wrote a paper about augmented and virtual reality. And in that one, he proposed an idea of using multi-sensory augmented and virtual reality. Is that right, Carlos? So he said we should include scent, like smell, in addition to augmented reality or virtual reality. It's a good idea. If I am creating my hypothesis, I can cite that to support my proposition, but it's not a strong theoretical support. It is still very exploratory because nobody tested it, but I'm using his argument to build up my hypothesis. So two different things, right? Now, in some cases, what happens is because there's other reasons for using TLS, right? So 4 reasons, right? So it's also possible where you have a strong theoretical support, like you have it, but your respondents are too few. Then what do you do? Then you have to pick up one of them, right? So it's not only one thing. That's why I said initially it's not straightforward. There's multiple things you need to decide on. Okay. Second question. Okay, very good question. Okay, but it's a detailed answer. So let's go to your third question. I'm going to come back to your second question. Mm-hmm. And yes, and the fourth one. Okay. Oh. Okay, so let's do with this. No, it's okay. Let's go with your normality and sample size and then go to predict one, okay? So sample size, it's not always easy to collect data, okay? It's very, like, let's say if you are focusing on uh, people with mental disability who travel, so where are you going to collect data? Like, there's not a lot of data. Then tourism itself is a whole business. It's not only consumer data, right? It's also all types of data. Let's say you want to focus on people who manage luxury golf resorts. Don't have too many people. And even if there are people, how many of them are willing to talk to you? Not too many, right? So there's a lot of cases where you don't have a lot of data and you should, I mean, you will end up with small sample sizes. Also remember that sample sizes are relative to your model. So if my model is like 3 variables, which I recently published a paper in Professor Levin's journal, only 3 variables, uh, then you don't need too many people because your model is very simplistic, right? But these days we are going to more and more complicated models. You see multi-level models, nested data from individual level to collective level and all these different moderators and mediators. So the more complicated your model becomes, the more data you need, right? So this is another thing to your question. And then the third one is, when we say you need smaller sample sizes, it doesn't mean you go with 10 people or 20 people or 50 people. It doesn't mean this. And also remember that small sample size is not a justification for PLS. It's not. It simply means this. If you are in a situation where your sample size is small, PLS will perform better than CBSEM. This is what it means. It doesn't mean that to use PLS, you shouldn't collect data. I mean, if you are collecting data from, let's say, visitors going to Kazakhstan, there's a lot of people in Kazakhstan who travel, right? But because you want to use PLS, then you only collect data from 20 people. That is not a justification, right? So it's the other way around. Like if your data is really small, and PLS would perform better. Now, what is small? Like, how do you define small? So that also would depend on several factors. So you normally have to do a power analysis. So you need to go do a power analysis to see what's the minimum sample size required to run that model. So sometimes your model is not going to run because you just don't have enough power into your sample to run that model, right? So a small sample size still needs to be relevant to what your model is, okay? And then now the predict question, right? Okay. So what is prediction? This is very important for you, for us to talk about, okay? If I'm doing simple linear regression, you know what is simple linear regression, right? Simple regression, I have one independent variable, one dependent variable. So what am I gonna say? Satisfaction and loyalty, right? Can I say satisfaction is predicting loyalty in regression? So let's say this is my regression, this is my y, this is my x, okay? And my statement is y is equal to constant plus beta value for this and x1, okay? So this is the value of y would depend on constant and beta x1, right? Is it a prediction equation? What do you think? Are we predicting loyalty through satisfaction? Right? Are likely to be more loyal, but is it prediction? Okay, so I will help you, okay? This is not prediction. This is regression. Regression simply means what will be the value of y if x is here. You are not predicting anything, you are calculating. Okay, now when prediction comes into picture, how many of you use Google Map? You use, these days when you start your car, does your Google Map tell you, you will go to this place, it's gonna take this much time or something like this? It say like this or no? Yes? So Waze will also do it. Like when you start your car, I start my car, it normally, depending on what time of the day it is. So if it's in the morning, it tells me it will take you 40 minutes to go to your office. Even though I don't put anything, it automatically comes, right? That is prediction, okay? But you know, since I am in Antalya, I never got a single prediction. You know why? Because there's no data. I never used Google Map in Antalya. Remember, prediction is always based on training data set. You need to train your machine or your mathematical equations to predict something, right? This is one statement, right? One equation. If I have 100 times this equation written, then I can predict based on all these equations. One data set cannot predict anything. Remember, one data set can never predict anything, okay? So when we say PLS is a prediction-based software, there's a specific algorithm called PLS predict. You may have seen it, right? In Smart PLS software, it says PLS predict, okay? What is that PLS predict? Okay, how does it work? So it works like this. You go into Smart PLS, let's say you collected data from 400 people, okay? And then what you do is you go to PLS predict, it asks you to divide your data set into two, okay? One is the training data set. I don't remember what is the exact terminology, but it's training data set. The other one is a prediction data set. So what it does is it uses the regression equations from your training data set and use the same statement for prediction later on to predict something then. Now, is it the accurate way of doing PLS predict? No. Okay. I have a very good friend by name of Somya Ray. He is in Taiwan from India. He is the one who actually wrote the paper in Journal of Business Research about PLS predict. Him and Gulet Shumeli, right? Two people. I asked both of them to do a webinar with me on my YouTube channel. They both refused. And you know why they refused? Because they said there's not enough application of it yet, because this method is not the most accurate method. It's one data set, right? You split it, I mean, it's okay, right? It's like your tire is punctured, you use the Stepney tire to go somewhere, but you cannot ride the car everywhere with that replacement tire, right? It's like that. So to your question, Smart PLS doesn't predict things. It's a prediction-based software. What it simply means is that the focus is mainly on R square. Covariance-based SEM focuses on beta values. Okay, PLS focuses on R square. This is all what it means. It doesn't mean you are predicting things. Is it okay? You understand? Okay. Any other questions? Yes. You ask me the 3 questions in EMU and every time you tell me this. My question is very challenging. Then I'm scared, like, oh my God. Which were the 3 programs? R and Amos, okay. Okay. Um, okay. Okay. Let me ask you one question, okay? In R, which package did you use? Okay. Now, obviously the answer is in your own question, okay? So use M plus, you use MOS, and then you use R. The package is also covariance based SEM, okay? So when we say covariance based SEM, it's not like you go and do the calculations. The formulas behind the program do the calculation, and the equations are inclusion of everything, okay? So the first reason is if you go and use any other PLS program, even if you go to R and use the PLS package, your answers will be similar to smart PLS. If you go and use, let's say, WAP PLS or any other program that does PLS, your answers will be similar to smart PLS, okay? Mm-hmm. No, no, no. Okay, okay. Yes, you did. So here, okay, let me ask you something. You make this model in MOS, okay? Can you run it just like this? Yeah, I mean, just assume there's observed variables in it, yeah. Or is it going to ask you to do this? It asks you to do this, yes? Okay. You still cannot run it. It will ask you, so how you tell me you don't have covariances? Look, I know. Yes, I know. What I mean is you have additional equations in your model. Okay, I mean, right now when you look here, this one is covariance. Yes? Okay. It also creates additional regression equations. It also creates shared variance out of these, right? So obviously your results are going to be different because your model is having more things in it now. PLS doesn't have these things, right? So this is one, and this is a very simple example. Normally your models are not like this. You have too many things in your model, right? So when you add too many things into your model, your results will be different. This is why I'm telling you, if you use any other PLS software, WAP PLS, any other Edanco or any other PLS software, your results will be similar to smart PLS, not similar to MOS or anything else. Similar to smart PLS results, okay? Now, to your other question, if your reviewers are asking you why you don't use MOS or use MOS and how you justify, this is where you go back to become a researcher, okay? Remember these softwares, as much as I love technology, as much as all my friends are working on future of technology, these are not intelligent softwares. These softwares work for you. You don't work for them, right? So you need to determine based on your research question, based on your methodology, which approach is the right approach for you, right? And whichever approach is the right approach for you, you need to use that one, right? And then even if the reviewers are asking you to use the other approach, you need to justify your choice. You know, I recently, after a very, very long time, somebody questioned my use of PLS, okay? I spent more than 2 weeks to write a response. I can share with some of you. My response was 6,000 words, only to answer why you use PLS. 6,000 words, it's a new paper, okay? How many of those words I use in my paper? Zero. All the work I put in 6,000 words, it's waste. I didn't use a single word of it in my paper. But I was confident on my choice, so I write it. I explain from so many perspectives on why it's like this. So if you are confident as a researcher on your choice, and which should be based on literature, which should be based on proper reading, right? Not just pick up smart PLS because it's easy to use. right? Some people also make this type of comment that many people use smart PLS because it's easy to use. So what? I mean, it's easy to use, so what? And, nowhere it says researchers can't use easy things, right? You can, but you need to justify this. Now, you can, argue with me for 5 days. I will tell you the same thing. These two are very different approaches and their assumptions and their applications, and you need to decide which one works for you. Okay? All right. Very challenging question. No, 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 I'm kidding. Ask questions, it's okay. Any other questions? No more questions. This side is so quiet. This side, no, ask no questions. Why? I can predict. PLS predict. Okay, good. Sure. Feel free to ask, okay? If you have any questions, yes. Let's take a break. I actually want a break. Yes. How long we have already gone? Maybe 1 hour, right? Yeah, let's take a Really? Oh my God, I talked so much. Okay, let's take a 5 minutes break. Yes? Sedan is the boss. I'm checking with her. Okay? You will not lock us out, right? 5 minutes? Okay. Okay. Yeah, mine. Thank you. This is not mine. Yeah. Okay, so whoever is eating in front of me, I have a problem with you. I'm so hungry. Okay, I'm kidding. I don't know why people take it seriously. Eat. It's okay. It's okay. All right. So it's a yeah. It's happy to see most of you back. Normally, this topic is very boring, so usually people run away. You know, most of the places I go after break, it's like the half class break. There's not a lot of people, right? So I hope you all learned something. Yes? Okay. Because of the time limitations and also the technical problems, uh, I cannot go there to use the software. So I think we will focus on the conceptual part, which we were doing now. Those of you who really want to learn the software step by step, my YouTube channel has probably 7 or 8 videos, step by step, every step, right? Where to click, what do you get, all that. So you can obviously watch that one, right? To understand the software. I think the stuff that I'm talking now, you probably won't find in a lot of places, right? The conceptual issues when it comes to smart PLS or PLS for that matter. So we'll continue with this depending on the time. If somebody is really interested to learn the software, tomorrow I'm free the whole day. So just find me. If you find me, put me in a chair and I will guide you how to do the smart PLS. Okay, we will certainly, I will help with that one. Okay, so let's look at usage of smart PLS or SCM in Scopus research. So if you look, it actually in 1980s, people started using it, but really after 2000, the usage started too much, right? Really a lot of people started using SCM. This is not PLS, this is generally SCM. The amount of research papers that use SCM published in Scopus journals, it really increased. And then this is why many journals now don't like SCM because so many people use it, right? I again, my personal belief or what I think is it's not a good idea to ban one method, right? I personally feel that because more than SCM, people use descriptive statistics like mean, median, right? So maybe after 1 or 2 years, editors might say, if somebody use mean median, we will desk reject, right? It's not a good idea generally, right? So we see this one. Siddhan, next slide, please. Did it change? Yeah. So what I will do is I'll quickly skip through these, but these are all review papers. These are different review papers. They have looked at different disciplines from one time period to another time period and really look at usage of CB, SEM, and this and that. This paper was done in 2016. They look at the usage of SEM in international business from 1990 to 2013. You look at the contrast. Most of the people use CB, SEM, 379, and then 45 papers using PLS, SEM. So not that much of usage, right? Next slide, please. Yeah, just bring everything here. Okay, yeah, this is one of my papers. I'm very happy about this paper. It's a funny story about this paper, but this slide that you see in front of you is one of the slides that changed my career. I presented this as a conference paper in 2015 at Rosen College, where I was telling some of you that story earlier. I presented this one. We had around 4 editors sitting in the room where I was presenting usage of SEM in hospitality. Professor Fevzi was sitting in the room. Professor Abraham Pizam was sitting in the room. And then Ellen File was sitting in the room, and Professor Perry Hobson was sitting in the room. I was not as confident as I am now. I was very scared. I just finished my PhD, went to the States. And, you know, many people ask me questions about SEM because, you know, many editors hate SEM, right? And I was talking about how to use SEM. So obviously the session was not so good. But anyways, the good thing was my presentation was right before the break, the lunch break. So the entire lunch break went into the discussion, you know, so I didn't go to eat. Many people didn't go to eat, and we were talking about SEM. On my way back from the conference, driving back to my home, 4 hours of drive. On the way, I got email from Manuel, who is now the editor for IJHM, asking me to be coordinating editor for IJHM, having no papers published in IJHM, but he asked me to deal with the methodology papers, and that was the change of my career, moving into editors and this and that. Just a side story, nothing to do with SEM. But this paper, actually, I started, the idea was really looking at how people use SEM or PLS into hospitality research, right? And you can have a look at it. There's several other papers that have also talked about them, but in hospitality research, when it comes to usage of SEM, these are the reasons why people use SEM, okay? So you see 71% people use it because of causality, right? So cause and effect, like independent and dependent variables. Then 45% of them include reasons like mediation or moderation in the model. And then 13% of them use it for scale development, right? So these are the main reasons why people use SEM into hospitality research. Next slide, please, Siddhan. If you really want to understand the idea behind SEM and, you know, what are some of the mistakes people make, this is one of the best papers you can read. I would highly recommend all of you to read this paper, because it's not only talking about SEM, it also talks about the problems with SEM, right? So people are using SEM without realizing what are the issues in them. And I can talk about some of them and you will understand what these problems are. So in this particular paper, it talks about these 6 main issues, right? And these issues are the issues people ignore when they use SEM. And this is in tourism research. So the first one is sample size, which I explained to you earlier in detail about sample size, right? Small sample size, large sample size. The best thing you can do to yourself is remember, research community is progressing, right? It's going further and further. Earlier, Gohan was presenting, and then another student, Burju, right? Yes, and Professor Jalil asked them a question about validity, right? How valid is your sample? How valid are these people you are asking questions, which is becoming so much more important in research now, right? So it's not only you tell people where is your sample coming from, you need to provide further more details to make sure that your sample is valid. And one of those things is called sample size. It's very important that you comment on your sample size, okay? Very important. How can you comment on your sample size? So normally I've seen people saying that my sample size is good. And actually my own sister made that mistake also. Earlier I was checking her presentation. She said, I have 42 items in my questionnaire. And according to some researchers, you need to have 10 respondents per item. So my sample size is 420 and this is good enough. This is actually a wrong interpretation. There is nowhere where it says you should have 10 respondents per item. It's never like this. I'll tell you how it works, okay? So it works like this. So the paper that many people cite, about 10 items per respondent, actually says you should have 10 items per parameter in your model, not per item in your model, per parameter, right? So let's assume this, okay? So I have a model like this. Okay, and let's say this model, I have 2 items. And then this one also have 2 items, right? So let's say if I go with the misinterpreted reference, which is 10 respondents per item, here I have 3 and 3, 6, 8, 10, meaning I need to have 100 respondents, right? Now, if I go to the original reference, which says you need to have 10 respondents per parameter, so let's count now parameters in this model, how many parameters I have, right? So each of the item have one error term, right? So it become 20 arrows, right? Because there were 10 and now it's 20, 21, 22, 23, 24, 25, 26, 27. Yes? So basically to run this model, you need 270 people, not 100 people, right? If you go with the correct interpretation of the reference, yes. 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 Mm-hmm. Yes. So remember one thing, when it comes to research, right? Researchers love to talk. Yes. You look at me, I love to talk, right? I'm on the stage so fresh, I love to talk. And when there is nothing to talk, they make up the talk, right? So what happens is whenever you look at guidelines, okay, guidelines, any guideline, anything, forget sample size, forget about that, any guideline, you will always have multiple guidelines about something, right? There's no thing in research that have one guideline. Everything has multiple perspectives. So you are absolutely right that 10 to per item is for PLS, but it is not 10 to per item for PLS. It says you need to pick up the most complicated variable in your model and then 10 times according to that one, right? So it's a bit different. And again, it's because PLS goes with smaller sample sizes, right? So if I look at this model, the most complicated one is this one. Then I look at the arrows here, and obviously it would be much less sample size. The problem is that I do not agree to rule of thumbs, because rule of thumbs don't mean anything. People change their models, disciplines change and everything. And that is why I always recommend my students or people I train to go with optimal sample size. Forget about minimum, maximum sample size and all these things. Simply go with optimal sample size. What is optimal sample size? It simply means you need to have enough people to run your model. That's it, right? So as far as you have enough people to run your model, you should be good enough, right? It's no minimum, maximum, nothing. And then optimal sample size also includes things like how much power do you need in your model, how much is probability you need. So it's really statistical things you need to include in it, right? We call it power analysis. So earlier I recommended one student from EMU also run power analysis. As far as power analysis tells you this is what you need, then you are good to go. Okay. Most of the journals now, actually the top journals require you to mention sample size adequacy, right? I ask, if I review a paper, I certainly ask people, please comment on your sample size adequacy, right? It's very important that you do that. So my suggestion is go with power analysis. Now I also want, yes. Mhm. Yes. Mhm. Yeah, my suggestion is go with power analysis, okay? Because power analysis cannot go wrong. Now, again, the power analysis is simply going to tell you how much you need to run the model. So as far as you are covering enough sample size to run your model, you should be okay. Now, normally when somebody tells me go with rule of thumb, I tell them, okay, let's assume this, okay? This model, very simple model, I have satisfaction, price, and quality impacting on loyalty, right? So let's say I want to collect data from my students who are taking my SEM course and they pay me $50 each. Just assume, okay? In the class, there is 50 students, right? How am I going to collect data from 100 people if there is only 50 people in the class? I cannot do that, right? So there's a lot of situations where minimum and maximum don't matter anymore, right? Now, the same model, if I want to conduct the same model on, let's say, customers of McDonald's, everybody who eats at McDonald's, and I go with 270 sample size, people are going to ask me, how generalizable is it? Because customers of McDonald's are in millions. So 270 again doesn't mean anything for a bigger population, right? That is why I think optimal sample size is the best justification, saying I have enough people to run my model. Now, if I go with this model, my power analysis may give you 70, 65-ish as minimum sample size, right? So let's say I want to do my study on McDonald's, okay? And my power analysis say that you need at least 65 people to run the model. I can collect data from 6,500 people. Nobody will question me because I'm fulfilling the optimal sample size, right? But if I go with this method, which says that I need 100 people, and there's only 50 people in the class, I have no justification there, right? So that's why my suggestion always is to go with power analysis. It's a much better way of justifying sample size. Yes. In PLS, yes. The number of arrows that goes towards the dependent variable if you are not using power analysis. In power analysis, you need to provide how many variables are in your model in total, regardless of independent or dependent. So however many constructs you have in your model, then you need to put that one in power analysis. Now, the rule of thumb for PLS is that you need to take the variable that has the most amount of arrows coming into it, right? So let's say if my model is like this, and after loyalty, I create another one which says word of mouth. Now my ultimate dependent variable is this one, right? But this one is only having one arrow pointing to it, whereas this one is having three arrows pointed to it. So I'm going to consider this one because this is getting most amount of arrows towards it for PLS, if you are using this rule of thumb. But if you use power analysis, then this entire discussion doesn't mean anything. Yes, yes. Also, for some of you who might be using multi-group analysis, like let's say if you are going to run an analysis, but you have two groups, right? Let's say we want to test this model in this group, right? But I also want to see what is the difference between male and female respondents here. So it's multi-group, right? Now, when you run multi-group analysis, you also need to make sure that each of the group has enough power, meaning now, let's say for this model, I need 65 people out of power analysis. And if I do multi-group, now I need to have at least 65 in each group. If I don't have 65 in each group, that means I cannot run the model for at least one group because I'm not dividing the model. Model still remains the same. I just am testing it on two different groups. Does it make sense? Right? So all these things are logical. Like you've got to understand why we are saying these things. Okay? Questions? Yes. Yes. So pilot study, you need to think about pilot study and answer a question, why do you need a pilot study? Okay. So there is multiple reasons for using a pilot study. One of them is, okay, let's say again, going back to the same example, my friends from Iran want to conduct a study in Iran. They get a questionnaire, they convert it into Persian, and then they now, before they go ahead and ask 400 people about something, they want to go for 20, 30 people and ask them, is it easy to understand? Do you have any problems with these wordings, terminologies, or things like this, right? That is why one reason why we would do pilot study. Yes? So for that, there's no sample size requirement. You just need to have, a few people who can tell you, is it easy to understand or not? That's one reason why we do pilot study. Now, another reason is where, and many people do this, many students especially do it, where they collect data from 40, 50, 60 people. And then they say, I did my pilot study to check reliability. And I did Cronbach alpha or something like this. Yes? Absolutely wrong. Because if you are picking up your skills from somewhere already established, let's say if I'm doing surf call, okay? 20,000 people applied it before, okay? Why do I need a pilot study for it? If 20,000 people are telling me it's the correct measurement, why should I go to another 20 people and ask them, right? Now, in this situation, if let's say I want to create something new, maybe for surf call, or maybe I feel that I want to collect data from hotels, but surf call doesn't really do a good job of assessing service quality of hotels. So I bring questions from different places, put them together. Now I need a pilot study because I mix so many things. It's like a Russian salad, right? So now I need to check with people, does it taste good? 20 people, 30 people, 40 people, right? Something like this. So you need to be clear why you are doing pilot study. Is it really needed or not? Also, there's a difference between pilot study and pre-test. Okay, so what I just explained about wordings and this, those type of things are called pre-test. Normally you do it to test your questionnaire. Is it okay or not, wording wise? Okay. Any other questions? No? All right, let's continue then. Okay, so we talked about sample size. Wow, it takes a long time, right? Okay, the other one is model complexity. Now, what does model complexity mean? Very important, okay? Sometimes you may have seen things on social media. It says, this only happens in Turkey, or this only happens in Pakistan, right? A person on motorcycle put a cow on the back and go, right? Or a person is going with some other funny things on the motorcycle and going, something like this, right? I'll just say, this happens in Iran only, this happens in Pakistan only. I never saw it, this happens in America only, because police put a lot of fine, right? So why I'm saying this is because everything has a limitation. Okay, everything has a limitation. Now, usually you would know that if this mic, right, this mic normally is supposed to take audio from one source to make it clear. This morning, what happened? The mic was taking audio from two sources and everybody was confused what's going on, right? It was too noisy and everything. Everything in the world has a limitation, right? You need to know the limitations. And if you go beyond those limitations, you are either not going to get the desired results or either you are going to destroy the stuff, right? Most of us have voltage issues, right? I travel a lot, so I'm carrying a universal charger with me. So it works everywhere. Otherwise, it doesn't work, right? So with the softwares, there's also some problem. There's something called limitations. Each method, each algorithm, each system has limitation, okay? Most of us use Amos, right? We all use Amos. If you go to Amos manual, they have a manual published by IBM. The manual says for best results, do not exceed 7 constructs. The manual says, okay, I'm not saying it. The people who develop the program are saying that for best results, do not exceed more than 7 constructs. I see models, 20 constructs, 21 constructs, and then they say the model doesn't work. Let's delete everything. Let's delete everything so the model works, right? I mean, if the manual is saying it's not going to work, it's not going to work, right? So model complexity also deals with situations like this. Now, how many of you think this one on the board right now is a how many of you think it's a simple model? Simple, right? 4 variables. Okay. Let's say I put one moderator, okay? Environment. This is a moderator. How many variables do you see? 5? Yes? Do you know how many variables are there in this model right now? If I use one moderator, let's watch. So for this to be a moderator, it also needs to be an independent variable, right? Okay. So we have 5. All right. Now I have interactions. This. So how many I included now? 3 more, right? So what looks like 5 is actually 8. So for a simple model like this, now I can add another moderator. Sometimes people also do mediated moderation, things like this. So every time you add something to a model, it complicates it. It brings more things into the model, right? And of course, that model complexity, many of us ignore. When you are writing your results, interpretation of results, we are ignoring a lot of these things. So I'm only going through these points. A lot of details of these points are in this paper. So please read this paper. It's good for your own understanding of the ideas. Prediction-based modeling, I earlier explained in your question, like we call it prediction, it is not prediction in origin, it's not, right? So that's another issue. Data normality, again, a very, very big problem. You know, it's surprising to me that how many people do not test data normality before running SCM. SCM is a parametric test, meaning your data needs to be normally distributed. Now, how many of you know what is normal distribution? Yes. Yes, but what does normality actually mean? Like, okay, you just started your PhD 2 months ago, 3 months ago, 1 month, right? Do you know what is normality? Okay. So you might be thinking like, what are these people talking normality, right? What is the easiest way to explain normality? I will give you a very, very easy example. How many of you know how to boil rice? Boil rice. Birinj. Yes, right? Many of you know that? Yes? Okay. Now, when you boil rice, you add salt to it or no? Salt. Namak? Yes, you add salt. At what time do you add salt in the rice? when there's water in it, right? Why? Perfect. We add salt into the water while boiling the rice because it dissolves and the salt is equally distributed everywhere, right? This is called perfect normal distribution of salt. The same thing needs to be in data. The same thing, okay? You all are sitting here listening to me about a boring thing of SEM. It means you all were in school one time, right? Many years ago, maybe not many years ago, but a few years ago. In your class, how many students were really, really, really good? 1, 2, right? How many were really stupid? Most of them. So normally the very stupid one would be similar amount, maybe 1, 2, very stupid. Some of them are stupid, some of them are good, and some of them are moderate, and then some are in the middle, right? This is equal distribution, right? Now, if you go to a class where everybody is genius, you will be surprised, right? What's going on? Why is everybody so good, right? Or if everybody in a class is very stupid, again, you will be surprised, like what's going on? Yes? This is the problem with non-normal distribution of data, right? So data needs to be normally distributed anywhere in the world for anything. For anything, there's an equal distribution, okay? And it is very simple distribution. It says like this. So there's a neutral point for everything. Then there's extreme positive, there's extreme negative. And we normally say that around 2% people are extreme negative. I'm making approximate. I'm not going into decimals and whatever. 2% are extremely positive. Then there's another one, like around 5% here, 5% here, right? And then the rest of them are in the middle. This is normally what happens, right? Now, in some cases, what happens is this. Like this, where most of the people are negative. We call it skewed data. Yes? And then in some cases, we have most of the people here. This is also skewed, but positive skewed. So you may have people who are very positive about something, or you may have people who are very negative about something, right? Either case, it's not a good idea. This morning, how many of you listened very carefully to Professor Fevzi? All of you? Do you remember he said something? He said, when I'm very happy, I don't make decisions. When I'm very upset, I don't make decisions. Right? It's a classic example of skewness. And when somebody is extreme, like when all your population or all your sample is extremely positive, then it means your data don't have variance, right? The beauty of research is if there is 50 people here, I want everybody to have their own opinion, right? How many of you teach? Many? Teaching. How frustrating it is when you ask students question and nobody asks a question. Frustrating, right? Very frustrating. Okay, why is it frustrating? Because when I ask a question, it means I want your opinion. And if there's 50 people, I want 50 opinions. When nobody asks a question, meaning all of you don't have any opinion, meaning there's no variance, no difference. And that becomes boring because we don't know what's going on. So if you are doing research and there's no variance in whatever, the research means nothing. Your R square will be 0. If you give questionnaire to people and everybody click on neutral, do you think you will get any data? No, there's no opinion. Everybody says neutral, right? Like this. I do this. Sometimes people ask me, what do you want to eat? I say, whatever, it's okay. They're very angry with me. Like, come on, I'm asking you, what do you want to eat? You say, whatever, right? Because it's a neutral opinion. So in some analysis like SCM, it's very important that we have normal distribution of data, right? Like we should have normally distributed data. Now, the problem is that in social sciences, when we ask people, it's almost impossible to get normally distributed data. Why? Because when we ask people questions, they have biases, okay? I can write it on oath, okay? If I ask you 50 times, do you think it's a boring lecture? Nobody will say yes. Even inside of you, you are saying so many bad things to me, okay? But nobody is gonna tell me on face like, professor, it is so boring. Right? Bias, right? Social desirability. We don't want to look awkward. Yes? You imagine somebody tell me like, what are you teaching? Everybody is gonna look at them, right? Yes? Social desirability, we don't want to do that. Yes? So this type of things happen in social sciences, right? So in social sciences, very difficult to get normally distributed data. And then culture is also very important. Like culture, because when we ask people questions, this is in one context, right? Either they are eating or with friends or doing something, or you ask them about an experience which is bad or maybe good. Sometimes you might ask people some questions that bring back bad memories for them or very good memories. So all of these things are going to impact normality of data. People are going to say different type of things. So we cannot have really normally distributed data when it comes to social sciences, right? So most of the data that we have is non-normal. Now, statistically, there are different methods to deal with it. Right? So for example, the one method of that is standardization. Right? So many people use a standardization method to standardize their data, okay? How it works, a very basic example I will give you. So they look at the distribution of data. So this one is negatively skewed, right? Then even though it's negative, then they take the median of this one. And then this side, they say negative, this side, they say positive, right? So for example, in many countries, when you ask people which political party you support, they say, you know, all of them are bad, but I'm gonna pick up the least bad person, right? Many people are like this. In my country, it's like this. So that's standardization of non-normally distributed data. Make sense? Yes? Anyways, but I feel that when you are standardizing the data, you are actually manipulating the data because it's not real data, right? You manipulate it. And as far as I understand research, manipulation is not good. But this is widely accepted, right? Everybody accepts this one. So I don't do this. And that's why I use PLS everywhere, right? So this is what it is. Then, yeah, I think we talked about weak theoretical support earlier with your question, right? You asked me a question about theory support and hypothesis and this, right? So we did that one. Formative and single item constructs, we will leave it for the next slide. Okay, it's, yes, Professor Jalil. Yes. 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 It's good that you remind me. Actually, I was going to talk about this, but I completely forgot. So when we are using SCM, right, and everybody says you need to test your data normality and what happens is very interesting. So you need to think about it like this. How many of you in this room feel hot all the time? Like you feel hot normally? I feel very hot all the time. Hot, yeah, like hot. Like right now, I don't want to wear this jacket. I'm feeling hot. Okay. Last night I came wearing shorts. I feel hot, right? So many people, not many people. How many of you feel cold all the time? Oh, that's why you wear this? Okay. So if I look at this room, several people, you can tell me your individual preference. I feel hot, I feel cold, blah, blah. But there is a central air conditioning in this room, right? It should be somewhere there, which controls the temperature of this room, the overall room for everyone. Yes? The difference between univariate and multivariate is this. So each of you, your temperature is univariate. You tell me about your temperature, right? But if I want to know the temperature of the room, right, that needs to be the central air conditioning for everybody, which is multivariate, right? So normally how we assess the normality is skewness, which is how positive or how negative it is. And the other one is kurtosis, okay? What kurtosis means is, so one model looks like this and the other one looks like this. So you can see that here in the first model, there's more people in the center, meaning there's a lot of people in the center, right? Whereas the other one, there's just very few people in the center, right? It's like this. So obviously, this one is not very normal. This one is normal, right? So this is how skewness and kurtosis works. So now, if my data is like this one, it will be normal based on skewness. Skewness is normal, right? But kurtosis is not normal. Okay. If my data is like this, skewness is not good, kurtosis is good. And that's why sometimes when you see those numbers, one is normal, one is not normal, right? This is how it is. But when we talk about univariate, it's like this, okay? So let's say I have two variables, satisfaction, loyalty, okay? And then for satisfaction, I have satisfaction 1, satisfaction 2, two variables. And for loyalty, loyalty 1 and loyalty 2. And let's say we look at mean, and there's 5-point scale. The mean for this one is 4.12, 4.69, 3.44, and 4.03. These mean values are for each of the variable, right? We are talking about one variable. So if I do skewness, and if I do kurtosis, right, it will be the same. So let's say 1.96, 2.44, 3.21, 1.91, and blah, blah, whatever. So these values are for each of the item, right? So normally when you have this skewness and kurtosis, we call it univariate normality because it's showing you normality for each of the item, right? But am I using univariate method? Because I have two here, two here. So I have both of them. Then I have the latent variables in the model. Oh, good. No problem. Yeah. This boss is so difficult. Tough boss. Yeah. So when I look at my model is not univariate. My model is multivariate because all these variables are together, right? So how is it that I'm using univariate normality to run the multivariate model? It doesn't add up, right? It's like you put all the food items on the table, okay? Like uncooked chicken, spices, tomato, everything, and you tell people eat. It doesn't work like this. You need to put them together to cook them and then ask people to eat, right? So how do we deal with this situation? Like how do we do multivariate analytics, multivariate statistics or whatever? So one method is the, what is it, distance? Yes, yes. One is, I don't use that one. Okay, what I do is, it's very simple. There is a statistical calculator. What it does is, it gives you multivariate skewness, multivariate kurtosis. And what you need to do is simply copy all your data, like the entire spreadsheet, paste it there. It takes all of them together and give you one skewness and one kurtosis for the whole data set, right? Which is called multivariate skewness, multivariate kurtosis. Yes. Yeah, go. You have a question? Yeah, challenging one? Challenging? Just, oh, now you're saying my problem. Okay, tell me. Mm-hmm. Mm-hmm. Yes. Okay. Again, the same thing that I said to Sanaz earlier. When you look at research, there's a lot of different guidelines. Okay. It's not one guideline, it's a lot. So, during this COVID, when you go to different places, they check your temperature to make sure you are not having fever, right? In some places, they do it here and they have a scanner, they do it here. Some places it's here. Some places they have a kiosk, you go in front of it, it looks at, and all of them give different readings, plus, minus, whatever readings. We cannot say which one is good, which one is bad, and things like this, whichever works for you at that time. To me, in my experience so far, multivariate skewness and multivariate kurtosis is the best way to assess multivariate normality. It's the most reliable one. Okay, so I use that one. Why it doesn't work for Shapiro, Wilk, or others, I don't know. But there should be some reason, but I don't know. Yeah. Yes, most of my papers I use these two. Okay. Yes. 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 Yeah, again, different guidelines. So some people say plus minus 1, some people say plus minus 2. Plus minus 3 also I've seen. Plus minus 2 is normally the most used one, guideline for both of them. Yes. Yes. No. I'll tell you why. So let's say if you have around 20 items, just like this, right? Okay. Let's say in these 20 items, 11 of them, both of these are normal. Okay. 4 of them, both of them are not normal. And 5 of them, either one was normal. So what are you going to conclude? Is your data set normal or not normal? That's exactly the answer. You cannot make a conclusion, right? So you can tell me, yes, some of them are not normal, but I can tell you most of them are normal. Like 11 of them are normal, right? And then 5 of them are partially normal. So it's more normal than not normal, right? But you cannot make that conclusion. And that is why multivariate skewness and kurtosis is important whenever you deal with multivariate statistics. Okay? Yes. What I will do is this, the folder that I mentioned, right? So I will add a link to it. There's a link. If you click on that link, it opens this calculator. It's called statswiki.com/something something. All you need to do is just copy your entire spreadsheet and paste it there and click on calculate. And within 2 seconds, you will get the result. Okay? Yes. Yes. Okay. Well, there was some other question. You Sarhad. Yes.
As far as I know, these two tests are tests for data normality, to check the data normality, but not for social sciences. They are so strict for the data for nature sciences.
Yes.
Because the data is not absolute.
That's true. One other thing very important for all of you, when you use SPSS, right, or any test for that matter, it's very important that you know the guidelines. Okay, in some cases, and most of the cases, we feel anything below 0.05 is good. But in many cases, if it's below 0.05, it doesn't hold true, meaning it's the opposite, okay? One very classic example of this is EFA, exploratory factor analysis, right? So before you do EFA, you also need to do sample adequacy, right? Which is called KMO and Bartlett's test, right? So many published paper in top journals I have seen where they say, because my significance is below 0.05, it means my sample is adequate for EFA. It's the other way around. Actually, it needs to be non-significant for you to proceed, not significant for you to be proceed, right? So very important when you use SPSS to really go and check the guidelines on what it says and how you should interpret the results. Okay? All right. Okay, let's one slide further, please, Siddhan. Thank you. Okay, yeah, further. Further. Yeah, further, please. Yeah, just keep going. I think all of this is simply different papers that have suggested using PLS. You will have the PowerPoint slides, right? So you can just go and check them out. These are all different papers. Please go ahead. Oh, yes, go ahead, please. Oh, yes, leave this one. Okay. Yeah, that's my paper, so I want to promote a bit. Yes. So this is the paper, the initial version I presented at the conference that I told you earlier. This paper has won, I think, 4 awards for me. Highly cited paper, hot paper, commended paper, Emerald Literati Award, IJCHM Best Paper Award. So this paper got all these awards. This is my highly cited paper published in 2018. It has 650 citations or something. Guess what? This paper was desk rejected by all the hospitality and tourism journals, except IJCHM. All of them, desk reject, okay? Not even review reject. I would submit it, it will come back. It's like a ping pong. Submit, come back, submit. Then I talked to Professor Okomosh. And I just requested him that, please send it to somebody who understands PLS. But anyways, even after that, this paper got 6 rounds of reviews. 6 rounds of reviews, got published. And then, like I mentioned, it's like that. The good part about this paper is, if you go one slide further, please. One more, please, Siddhan. One more, please. Okay. Can you go one slide more? Okay, whatever. The good part about that paper, I think it will come later on, is if you go towards the end of this paper, right, towards really the end of the paper, the last table actually gives you all the guidelines that you need to use PLS. So if you are using PLS, it starts with how do you prepare your data all the way to, latest guidelines, and also references to those guidelines to the papers where you need to go. Like I just mentioned, data normality, very important to report data normality, okay? I've seen several people telling me this, and one author actually fight with me during the review process. I suggest something, and it's funny, sometimes people think that because PLS can run non-normally distributed data, they don't test the normality. Actually, normality should be tested. What it simply means is, earlier, like I said, for sample size, if your data is normal, it's very good. If your data is not normal, PLS can produce better results. This is what it means. But for you to tell me is the data normal or not, you need to test it, right? And how much time it takes, maybe 1 minute to test and 1 minute to write the sentence, right? That's all. But some people just feel because it says one reason to use PLS is not normal data, and they don't do it. So make sure you test and report your normality. These are all different reasons for using PLS. Obviously, people cite sample size as the main reason, then data normality, relatively new constructs or theory development, which I explained earlier, formative constructs and single item. Normally, I would love to talk about formative constructs, but because some of you already told me it's late in the day, and it's a very complex thing to explain, formative constructs. So maybe we will leave it for another day, okay? But we can continue with other things. Model complexity, moderation, blah, blah. Sit on one slide, please. Okay, this is also one of the tables in this paper, my hospitality PLS paper. Here we compared a lot of things, and very interestingly, you can see that for when it comes to hospitality and tourism, you will see that most of the studies in hospitality and tourism report a reason for using PLS. It's very amazing that how editors and reviewers deal with PLS. So if you are using PLS and you did not explain why you are using PLS, I can write it for you and you can check it. I can guarantee you that either the editor or the reviewer is going to ask you, why did you use PLS? Please explain. Nowhere else people do this with no other. You use SCM, nobody is going to ask you why you use SCM. But you use PLS, then you have to explain why you are using PLS, right? Then the other one is very interesting. So you can see the number of latent variables range. Look at tourism. So one paper that have used SEM, the minimum number of variables in that model was 2. So it means like one dependent variable, then they use SEM. So this is the time where you don't need to use SEM, right? There's no need for that. So that type of situation, hospitality is a little bit better. So a minimum 3 variables used in a study, but look at the maximum numbers. 20, 17, this is where model complexity come into the picture, right? So many model variables into. Okay, then there's not a lot of studies using formative constructs, single item, blah, blah. Please one slide further, Siddhan. Another one. Okay, yeah, this is good. This is very important. So when people tell me you shouldn't use PLS, right? Or when they criticize using PLS, I always, and one thing I really thank Dr. Jihan is that I learned from him is always focus on the positives. I mean, there's a lot of negatives which you cannot do anything about, but always think about the positives, right? Which in this case also works. When you look at PLS, there's a lot of positives there as well, meaning there's a lot of recent developments happening, right? And I think you should always use these things for your research because when is the editors panel? Tomorrow? Editors panel? Siddha, tomorrow? All the editors will talk? Tomorrow, right? If tomorrow or day after, whenever, but you will see that most of the editors are going to tell you one thing. They will tell you a lot of studies are replication studies. I think Professor Fevzi said it this morning also, right? All the studies are replication. There's nothing new. We all know those things, which is true. In a sense, if you look at the papers, they're talking about the same thing again and again and again and again and again and again. But if you focus on these new things, new developments, I think you can make your studies much more interesting to people to read, and it can increase your chances of publishing those papers in good journals. One of them is IPMA. Okay, IPMA simply means importance performance matrix analysis, right? IPMA, very important. Many people in strategy use it. People in boardrooms use it as a strategy to focus on what is important and what is performance. How many of you like football, soccer? Yes, okay. Or any other team sport, right? Basketball, football, whatever, volleyball. They have these auctions or draft for players, right? And each player is sold for a lot of money. And one team picks up one player, one team picks up another player. How do you think they assess the value of these players? About? Right. So goals they score, their performance and stuff like this. So performance is how many goals they score. That's their performance. How consistently they do it would make their importance. Yes. And that is going to determine what's the value of it. So now if I have a model, in this model, I have 20 variables. Do you think all these variables are equally important? No. Do you think all these variables are equally performing? No. So if I have 20 variables and I have a bunch of hypotheses, I did my hypothesis. Now, maybe I should do an IPMA to tell the managers which of these variables are important, which are highly performing. So we provide more value to our implications. Does it make sense? Sanaz, you do decision modeling and things like this, right? fuzzy set and this. Yes. Yes. Mm-hmm. Yes. PLS. Yes. Yes, this is why it's important to focus on this because it provides more value to your research, right? So earlier I said about, let's say, skills, important skills for people to go into industry. If there's a bunch of skills, let's say 30, instead of picking up the top 3, why don't we put them into a 4-quadrant thing, which is important, which is also high performing, which is less important and more performing. Now, you all know Neymar Jr., Ronaldo, Ronaldinho, right? All these players. So Messi, yes. Okay. Is he a good player? Yes, definitely, right? Ronaldo, very good player. Are they performing in every match? No. Right. So now their importance is very high for the team, but it's not necessary for them to perform very well in all the matches. So when a star player doesn't perform very well, what happens? Substitute. Right? In the game, they put the poster, he comes out, the other one goes in. This is what happens, right? So now you have 20 variables, 15 variables, 18 variables. Not all of them are going to perform very well. Not all of them are important equally. So maybe put them into classifications, which one need more resources, which one need less resources. So just imagine for a moment, we are in an all-inclusive resort hotel, sort of. Yes. Yeah. So there's a lot of things here, but let's say if I say performance, low, high, and then importance, low and high. Now, there's a bunch of activities in this place, right? Right now, it's cold. Earlier I went, 2 people here in this room took me outside and said, let's sit in the sunlight. It was very hot, right? You put me outside there, very hot, I feel very hot. The swimming pool was empty, right? Nobody is in swimming pool. There's a water park, slides and stuff. Even though I see kids running around, but empty, completely empty. So performance is low for the swimming pool, right? How important is a swimming pool for a hotel like this? High, right? So I'm going to put swimming pool here. Yes? Buffet, eating. Important? Oh, right now it's very important for me. And the performance is also good because a lot of people are eating. I don't know if they like it or not, but they eat it. There's no other option, right? So I will put it into high here. What else? Audio, video, all this stuff. Important? Is it performing well today? Other than Siddhan make a joke with us in the morning, everything else was good. Yes? So I'm going to put audio, video here. Yes? Okay. How about casino? Is there a casino here? No casino. No, right? Okay. Yeah. Spa? Anybody been to spa? Anybody went to spa? No? No? I can't believe it. Come on. Yes, you went? How is it? Expensive? Okay, so performance is not good. Is it important for you? Is important for you? That's why you have challenging questions. Okay, let's assume for a moment that spa is not providing good services and the prices are high and they are not doing very well. So the performance is low and the importance is also low. Okay. All right. Now, these are my variables. So how do I deal with them? Of course, this is, if I look at this one, it's high performing, high importance. So the company need to focus on this one. Okay. But to focus on something, you need resources. How many of you read papers and managerial implications? They say the company should do this, the company should. How can the company do all these things? I mean, if the company could do all these things, they would have it already, right? So companies need resources. Now, where will the resources come from? This is low performance and low importance. So let's remove this and put these resources here. Say why? Because when you put resources here, this is going to come here automatically. Either way, right? The whole point is when you do IPMA, you can write your implications like this, which is much more meaningful. Does it make sense? Yes? Okay. So that's IPMA. After this is one more slide and then we can finish. Siddhan is very angry with me. Siddhan doesn't know what I talk, right? Yeah, one more slide, then we finish. Okay. The other one is hierarchical component models. Okay, this is also important because the phenomena that we are now measuring in our research becomes more and more complicated, right? Okay, so we are all at this conference. What if I ask you, how was your experience at the conference? Good or bad? It may be very difficult to answer that. How can I say that? Because there's so many aspects to it. Maybe you like the academic research quality, but maybe you don't like that two people are sitting together, right? Maybe you like this one, but maybe you don't like the color of the stage. There's a lot of things, right? We don't know. Maybe you like all of this, but you don't like that it's hot. Who knows? There's so many things, right? So when we want to measure these complicated things, we start with a lot of items, but then we put them together into dimensions, and these dimensions go to the overall construct we are looking at. Surf qual I mentioned several times. Surf qual have 5 dimensions. So if we want to assess the quality of this conference, which is a service, then we can look at the tangibles, we can look at reliability, we can look at responsiveness, empathy, and assurance, 5 dimensions. Each of them have additional questions. So in total, there's 21 questions. These are hierarchical models. Now, why should you use hierarchical models? Right? The question is, why is it important to use them? First of all, it's important because you don't lose meaning of things, right? When you put them into dimensions, everything goes back to the main construct. You are measuring all types of aspects of whatever variable you are measuring. Second, it makes your variable, it makes your model less complicated. Okay, so for instance, earlier I gave you an example. Yes. Yes. Mm-hmm. Mm-hmm. No. Yeah, no. No, yes, because normally when we measure it like this, let's say I want to measure loyalty. Okay. Loyalty means, do you prefer something or not, right? Like in terms of brands or services or whatever. There is normally 2 types of loyalty. One is called attitudinal loyalty, one is called behavioral loyalty. Attitudinal is your attitude positive towards something? Do you feel good about it? Do do you prefer it over other brands? And then behavioral is you show it through your behavior. You buy it again and again. You tell your people to buy it again and again, right? These type of things. So it works like this. I have attitudinal and behavioral, and it goes to loyalty, right? So it creates it. So usually conceptualization wise, it would be wrong to say positive and negative together create something, right? It's conceptually not correct. But in real life, that is exactly what happens. You have certain positives, certain negatives, and then the difference in MDM and HCM, higher component models, is in MDM, you are looking at decision modeling, and decisions are based on value proposition, meaning positives and negatives, right? So if positive is higher, then you go more positive. If negative is higher, you decide not to do it, right? Higher component model is different. This one is measurement strategy. So it doesn't show behavior or decision. It simply shows measurement. How do you measure that one, right? So you can actually use HCM to measure something and then use that measurement into MDM. Does it make sense? Right? So something like this. So maybe if surf qual, you can use as a higher component model to measure service quality, and then use service quality as one of the criteria for MDM. Yeah, this is how it's working. Okay, what was I saying? Yeah, model complication. So let's say we want to see the quality of service in this conference, and if it would make you come to MTCon again and again and again and again, right? So there's two ways of doing it. One is I do tangible, responsiveness, reliability, empathy, assurance, loyalty to conference, right? Loyalty to MTCon. How many hypotheses are here? 5? Yes. Now, maybe I also want to see, yes, the conference is good. It looks nice. Tangibles are good. It's very responsive. Yeah, responsive. Everybody answer very quickly. It's also reliable. We do whatever is supposed to be done. Empathy is also there, and assurance is also there, right? However, all of these will obviously make me come next year to MTCon, but there's also another catch. It depends on where is it going to happen. Location. So all of this is good, but if Professor Muharram decides to do it again in Antalya, maybe I will not come. I'm just making it up, right? Because I already came to Antalya. Why would I come to Antalya again? Right? So all of these won't matter if the location, right? So this is interaction now. So if I do this, now how many hypotheses I have? 10. Actually 11. Right? So instead of doing all of this, and the more complicated your model is, the more difficult it is to make it model fit. So you keep deleting things, right? So instead of this, what I do is service quality. These are dimensions, only one hypothesis, 3 hypotheses instead of 10. These are not hypotheses, these are measurements. Yes, 5 minutes more, or you are saying goodbye, we are leaving. Oh, I am also done. There's one more slide, Siddhan. Yes. Yes. So HCM is part of SEM. Okay. Here, look, structural equation modeling means you are modeling your equation in a structural way. This is what it means. Okay. Now, you know, normally regression equation is written as y is equal to constant plus beta x1 plus beta x2 or what, things like this, right? This is equation. But if I want to make it look like a model, I draw the model. Yes? Okay, just for one moment, if I remove these 3 arrows, meaning if I remove the arrow between service quality, loyalty, and location, I don't have a structural model. I don't know what is the structure of this model, which one is independent, which one is dependent. I don't know any of this, right? I have these arrows, but these arrows are not structural model. These are measurement. This is showing me how I am measuring service quality. It's not structure. Structure is hypothesis, right? Now, when I add these variables here, these arrows here, now I have structural model, right? So to your question, HCM is measurement. Structural model is hypothesis. Both of them are important. Now, can you run a model without HCM? Yes. If instead of service quality, I only look at academic research quality, which is one variable, not higher model, right? I can still run the model without HCM. With HCM, I can still run the model, but without structural model, I cannot run the model. Does it make sense? Okay. All right. So that is your HCM. The third one is, which one? Yes, confirmatory tetrad analysis. Yes.
HCM means second order or third order.
Yes.
Factors. That's the structural model. The rest factors allow us to do that. So I think the question was that. So what does it mean? HCM. What is it? Is it a special test or it is a kind of model? It's a kind of model.
Yes.
That PRS softwares allow us to do that because we sometimes use the second order, third order, or fourth order constructs to test the model. It just means you can do it in PRS.
Yes. So exactly. It means that you can use HCM to use complicated concepts in your model. This is what it means, right? So if you have a very complicated construct, meaning 3 levels or 4 levels, you can use it into PLS to simplify it by simplifying, right? So this is what it means. Sure. The third one is confirmatory tetrad analysis. Now, because we didn't talk about formative constructs, so this one is sort of meaningless to explain, but I'll just simply tell you, how many of you know reflective and formative constructs? Okay, a few. These are measurement ideas, right? How do you measure something? In some cases, the measurement is the consequence of the variable, right? And in some cases, the measurement is through the reasons for that variable. So either way, we call it reflective or formative. Now, in the past, it was difficult to decide whether the variable is reflective or formative. You had to go to the literature and see how people have used it, right? But it's not necessary that whatever people have done in the past holds true today as well, right? I mean, in the past, people made a lot of assumptions, but now we don't agree to them. So for me to tell you that this variable, which was studied as reflective, you should study it as formative, I cannot do it like this, right? It's not possible. CTA actually uses statistics to tell you whether a construct should be reflective or formative. So this is what it means. Obviously, it's a long process that you go through, which I'm happy to guide you to my YouTube channel. We have a detailed video there on how you can assess CTA through smart PLS. You can, but it simply tells you statistically if a variable is formative or reflective. Now, for you, if you want to publish in some good journals, I would highly recommend you to look at some of the most studied constructs in your area. SurfQual, published in 1988, actually 1985, but the proper one is 1988. From 1988 till 2018, okay, 30 years, people thought SurfQual is a reflective higher order model, meaning that the 5 dimensions are reflective in nature to SurfQual. Just in 2018, somebody proved that it's actually formative, meaning all these dimensions are important for service quality. You cannot exclude any one of them, right? So engagement is the same way. Many people studied engagement as a reflective construct. Now it's more formative in nature. So look at some of the most important constructs into your area. You have a very good chance of making a contribution if you can prove logically and statistically that this construct should be formative or reflective or vice versa. Okay, one more slide, Sedan. I'll finish very quickly. Yeah, just, okay, perfect. So this is a good multi-group analysis. Again, when we are collecting data, remember that in collecting data, we have different type of behaviors within the sample, right? Within the sample. So for instance, how many of you enjoy shopping? Oh my God. You also? The guys? Really? Oh my, that's why. Okay, now I know why you have challenging questions. You are shopping all the time. Uh, Normally, for female, they enjoy shopping more. Like normally, I'm saying generally. Men, yes and no, it depends, right? So let's say if I'm collecting data for the amount of time spent in shopping, leading to shopping satisfaction. Okay, let's just assume that this is the data I'm collecting. And then in my sample, I have male and female. What will happen is this, okay? So let's say if this is the graph, okay? Shopping satisfaction and shopping time. So now I collect my data and I run the analysis and it shows non-significant result. Okay, what happens? I am very upset. My results are not significant, right? What should I do? My supervisor is angry with me and everything, right? Blah, blah. So it's important that we try to understand what's going on in my data. Okay, so let's say I look at my data and I realize that in my data, there's a big group of male consumers for whom this relationship is like this, meaning the more time they spend in shopping, the less satisfied they are with shopping, right? But with female, it become like this. So for male and female, it become like this. The more time females spend in shopping, the more they are enjoying it and satisfied, right? Now, what is happening is inside my data set, both of them are canceling each other out. And as a result, my results are not significant. Because in my sample, I have two different groups that are canceling each other out, right? So usually what you need to do is, and I actually mix these two concepts, the multi-group and finite mixture together so that it's quicker to finish. Siddhan is saying again and again, like first she do like this, now she is doing like this. Uh, yeah, so usually at hypothesis stage, you should hypothesize different groups into your data, right? Try to see if there might be some difference based on gender, education level, or sometimes psychographic qualities or other things. I did a study on very recently, I was seeing three constructs in Professor Levin's journal. It's about how brands changed their logos during COVID-19 and if people love those brands for it or not, right? So brand anthropomorphism, brand love. But at the same time, Siddhan and I did this study together. So at the same time, we also wanted to see how people's general attitude towards social distancing might change these relationships, right? So some people thought social distancing is bullshit, sorry. Some people thought social distancing is a good thing. Obviously, they think differently, right? So how it would impact their perception of brand. So you can do this in your hypothesis development stage and you can test it. It will give you more interesting things to talk about, right? Finite mixture actually tells you when you put your data set into Fimix, it tells you if there are different groups into your data set. It is not going to tell you gender is a different group or age is a, it will just tell you that there is 2, 3, 4 heterogeneous groups into your data set. So it's you who need to go into your data and decide what are the differences, and then you can hypothesize and use those, right? And then the last one is consistent PLS, which is a new addition to PLS as well. To the question that one of you asked me earlier, is what happens if some of the criteria is met and some is not met? What happens if I am using theory development, right? But my data is not normal? Or what happens if my data, I'm doing theory confirmation and my data is not normal? Or what happens where my sample size is very small, yet I want to do theory confirmation, right? So whenever you have a situation where both SCM, some criteria here, some there, then you can use consistent PLS. So what consistent PLS does, it uses PLS algorithm, but it also provides you model fit and other type of indices so that you can combine both those SCM methods together. Yeah, okay. So I'm done, officially done with this, but let's take a couple of questions. Exactly. Yes. So if all your constructs are reflective, all of them, then you use PLS consistent, because all reflective model means you are picking it up from previous literature and you have a theoretical support for them, right? Yeah, yes. So I'm coming. If all your constructs are reflective, you generally use PLS consistent, right? Now, if some features are like, if your data is not normal, but you are doing theory confirmation, at that time you can use PLS consistent again, whether reflective or not reflective or whatever. Or whenever you are in doubt, then go for PLS consistent rather than PLS. And actually, I'll come back to you, but before I forget, to your question, which you earlier asked me, M plus and R and this, right? If you run PLS consistent, you will get similar results. PLS2? No. PLS2, nobody even give you support. If you go to Smart PLS help page and say I'm using PLS2, they will tell you goodbye. Seriously, I mean, nobody use it. Yes. And I will give you a free license for 2 months. So then you play however much you want. Okay. Yes. Yeah, everyone. I mean, here I will add the license to that folder. So when you guys go to that folder, you will see the license key there. Okay. But don't spread it, please. No, don't steal. Stealing is not good. Yeah. Yes, that I agree to. You have any other questions? Yes, because it's much tougher. The criteria is very strong. Yeah, it mimics CBSEM, so it's a bit tough. Okay. All right. Okay. I'm going to remove this one. It makes me feel like a cyborg.
Okay.
I'm going to go down.
Dear participants, we'd like to make an announcement about tomorrow's program. Please check the program with your QR codes on the badge. So in the morning, we will start again with the keynote speaker, Michael Hall, and also another speaker, Johan Wirtz. And also we have another workshop by Professor Carlos Flavian, and we'll have an industry speaker as well. So a very important part of the conference is the editor's corner, So I think everybody is looking forward to that. And please don't miss the session. And with another keynote speaker, Bruce Tracy, we will be together and we will end the day with the 5th workshop. And then I think everybody will feel more happy. The social activity will be, the bus will leave at 8:15 tomorrow evening. So what will happen to those who are attending the workshop? Are they going to miss the bus? No. We will arrange the time if we need more time. Yeah.